First, good afternoon, and thank you for the Mr. Madi as the host, and then thank you for China Society for Geographic Photogenics and Cartography, FIG, and Supermap for this event. Now, I would like to share about our projects in the 3D modeling and information system, 3D MODIS. The title is Heritage Smart City Planning, or we can call it HESTYA. The case study for this research is the area of palaces in Cirebon. There are 4 palaces, and this research funded by the Asahi Glass Foundation. Okay, first, before we are going to the HESTYA research projects, we have to talk about the background, about the urban condition in Indonesia. In an urban settings, buildings represent one of the most important elements. Building constructions requires more than 40% of the global energy requirements. In Indonesia, this has been more evident with the ever-increasing rate of urbanization. We can see in the left pictures is the increasing rate of urbanization in Indonesia. And then in this regard, a sustainable strategy to city building and planning is very essential. One of the most important pillars, this is 9 things that essential for the sustainable urban development, but one of the most important pillars of such development strategy is the availability of accurate data. And then about the urban management planning includes the urban service provision planning in accordance with urban service standards, and then planning and setting the strategic aspects in urban management. But this includes, but not limited to, urban zone planning, like a regional spatial plan. In Indonesia, we say it RTRW, Rencana Tata Ruang Wilayah, and detailed spatial plan as Rencana Detail Tata Ruang, and then zoning regulation, residential area plan, and residential environmental plan. And then it's about the technology and smart city. As we know, smart city is the cities that take advantage of advanced and digital technology or information communication technology to improve city performance. Then the concept of smart city has been proposed in past experience to help manage these issues. In a sense, the smart city is based on various digital technologies, all used to increase city performance, like we can see in the left picture, but there's some issues that if data inventory, who owns it, how to or who use it, and for what purpose. And from the Bappenas in Indonesia, the Sustainable City in 2015 until 2014 plan is about the city urban sustainable for the sustainable citizen, like strong neighborhoods, walkable, affordable, and etc. And then in Indonesia, although the concept of smart city has been implemented in several cities, we can say it Jakarta, Bandung, Cirebon, and other cities, but many challenges are still present. The first challenge is limited land because of uncontrolled urban growth. So it raises slums area. And then the second is limitations of basic facilities and infrastructures to meet the needs of the population settlements. And the third is social issues. We can say it, example is poverty and crime. Are prone to occur in urban areas. And then from these issues, we have to make a sustainable urban development, because there are several challenges that must be solved in the provision of settlement infrastructure. Then the background about the importance of data, as can be seen in the Sustainable Development Goals. We can call it SDGs. These 17 goals in here. But from the SDGs, there's a question: do SDGs need a 3D maps, and what are the specifications? And the other question is the map only for integration or aggregate analysis at the national level and reporting, or others? It is the SDGs chart. We can see it's from the circle of SDGs, and the waiting cake is like some different percentage visualization of SDGs. Okay, then it's same. We can see from the 17 goals in SDGs, there are the national indicator with 319, and then uh, in this slide, we can see the human and fire dynamics. In here, we can see the SDG 11 is to provide essential urban service, and other target we can see there is the issue of planning. On the issue of the planning, the UN Fundamental Geospatial Data include not only 2-dimension, but also 2.5 dimension and 3 dimension of geospatial data. We can see it in the document of GGIM. And then it's more specifically the spatial planning needs 3D map fundamental data set for spatial. We can see it is the public law and private law. In the public law, we can see the development of spatial plan and then implementation and control of space. In the private law, we can say that it needs right restriction and responsibilities with 3D maps, because there's object zoning regulation and building code. There's need the 3D maps. It is also the more specifically to improve the issue of sustainable city planning using 3D data. The data specification for usage, scope, and actors we can see in the phase and interpretation. There's one map policy to the spatial information and spatial data infrastructure. So it can be implemented the decentralization and regional autonomy. And then it is the big question, why 3-dimension? In this picture, we can see that third dimension is admittedly often forgotten. It's the multi-view spatial decision support systems. It is not only improve the visual, verbal aspects of maps, but also enables multi-view spatial decision support system. Sorry, because it's mixed in Indonesian and English slide. So from these issues, there are visual, verbal, mathematics, digital, and cognitive. So from those issues, we have to find the solutions. We argue that the recording of 3D geospatial data will become inevitable in the future, as can already be seen in several countries. It is the example. The spatial planning needs 3D map. It is the example for the 3D representation of spatial planning in the case of city of Bandung and Jakarta. In the left picture, it's in Bandung, and the right is Jakarta. You can see the location, the height of building, and then if we give the regulation and standard in the application, we can see how to manage the city planning in that application. And this is the this permit needs 3D maps. Yes, it needs because first in these diagrams, in these pictures, we can see that the parcel in buildings now not only in one floor, it's for the 2, 3, and it's a high building. So we have to make it 3D models. And then this is with the use of 3D data, standardization to 8 business permits can also be initiated. This would streamline the process and thus facilitate business owners that's dealing with construction permits, getting electricity, registering property, and paying taxes. This data standardization for ease of doing business. Land administration domain model has been implemented in Indonesia, but now GLADM is still developed to accommodate for the permit, city planning, and management like that is with the 3D. It is one of the example why permit needs 3D map. It is the Semanggi in Jakarta that using the compensation fund, using the koefisien luas bangunan KLB, that it and then the fund using the regulation about the area and height of building from the regulation. Okay, now like the COVID mitigation. Does COVID mitigation needs 3D maps? In this slide, we can see the market floor and the reroute that we can use to COVID mitigation using 3D maps. 3D data can even be used to help with COVID-related mitigation in terms of implementing health protocols in specific buildings with the help of 3D maps. This type of spatial planning can be implemented digitally and more efficient. It's like the left picture is pre-COVID and the right picture is the post-COVID. Before the COVID, we can see there's no yellow area. The yellow area is the exchange area because of the COVID mitigation. It is the pre-COVID, lockdown, and post-COVID. Okay, now going to the HESTYA research. First, and then I would like to tell about the 3D national mapping. Currently, the era of digitalization currently happening, whether we realize it or not, but it has brought society into the digital society. So we need the 3D geospatial data is increasing, like a digital twin. And the 3D mapping techniques tend to be faster and more accurate. So it has prompted several national mapping agencies to develop their traditional task of providing topographic maps into 3D geospatial data. It is one of the example in the 3D national mapping. In the research from Stutter, it's Switzerland's Federal Office of Topography, SwissTopo. In this case, it switched from 2-dimension to 3-dimension surveying and mapping in 2008, and the application that they created can be seen by public and private use, but it is the restriction for the public view. And then in terms of urban city models, nowadays various geospatial techniques can be used to derive the 3D data. Amongst others, the use of laser scanning, photogrammetry, SAR, etc. This is, I would like to tell about the 3D model. It is a representation of the urban environment with three-dimensional geometry, but building as the permanent feature. Okay. A system called GIS, Geographic Information System, enables the storing of both geometric and semantic data in a single environment. The system manage the data and can be used to perform analysis and modeling in 3D GIS, stores and manipulates 3D. It is a 3D geometric primitive built in GIS software and designed with a specific 3D modeling software. And then one of the standardized frameworks for GIS is the CityGML, City Geography Markup Language, which deconstructs geometrical features into several levels of details. It is the level of details in the OGC CityGML and the version of TU-Delft. In the OGC CityGML version, there are the LOD 0, 1, 2, 3, and 4. The difference is in the LOD 0, it's only a plan. It's 2 or 2.5 dimension. And in the LOD 1, it's visualize the building maze. And in the LOD2, we can see the form of the roof, but it's very simple. And then in the LOD3, we can see the more detailed roof. And in the LOD4, it's the detail for the interior. But in the version of TU-Delft, they create another version that more detailed than OGC CityGML. There are like LOD 0.0, 0.1, and so on. It's more detailed. And then it is the application from the 3D GIS that we can see from the one of the government agencies in Indonesia. And then another paradigm in storing 3D data exists in the form of building information modeling, or we can call it BIM. Unlike GIS, BIM works in a much larger scale. As the name suggests, it mainly concerns the scale of a building and its interior. The BIM also possesses a standardized framework in the form of the IFC. In this picture, we can see the process of building life cycle. It is need the building information modeling. And then, what is different of IFC versus CityGML? We can see the overlaps and gaps. There are difference in coordinate systems, geometry representing, and semantic representing. The difference of geometry we can see in the left picture. It is the difference of geometry, and then for the semantic we can see in below that the picture, and then for the CityGML and IFC there's overlaps in the building. CityGML not very detailed in building, but IFC very detailed in building, and CityGML can be modeled for region area, but IFC, if we model the region area, larger area in IFC, the data is very huge and it's not used. This is the case study for the HESTYA, the palaces in Cirebon. Why we choose the Cirebon? Because it is the conservation heritage area and then that's varying degrees of architectural complexities as well as being located in an urban setting. And then the third is architectural complexity also makes the documentation process more difficult than modern buildings. We can see in the picture, the first picture is the orthophoto of Kasepuhan Palace in Cirebon. And the below picture is one of the example building in Kasepuhan Cirebon. It's different with the modern buildings. And the research of purpose is to form a concept for the construction of 3D data models that facilitate the development of sustainable smart city for buildings in urban heritage zones using participatory mapping. And then the expected results, there are 3 results. First is a simple 3D digitation method based on SFM photogrammetry and basic surveying, which enables ordinary citizens to perform 3D mapping. We can call it participatory mapping. And the second result is development of a smart city system, which enables the public and the stakeholders to integrate their data. And then the third is the 3D models obtained from this whole workflow. This is the research plan for HESTYA from the data acquisition to point cloud, and then we can modeling it to the 3D map as the 3D GIS and the 3D building model as a BIM model. And then we store it in the open source application. This is in this research, we use the CMD build. CMD build is the application then can manage the city facilities and the data for the 3D GIS and building information modeling. And it has, we can see the visualization in that application too. And then that application, we use that application to be the assessment tool for the evaluation of building and environment. And then it is about the land administration and the land management. Is the why we choose the HESTYA. And then this is the HESTYA research. The project HESTYA, which as the name implies, tries to implement smart city concepts for urban heritage complex, is a continuation of the Kasepuhan experiment. And in the next projects, in next research, we make the case study is the 4 palaces in Cirebon, not only for Kasepuhan Palace. In this project, participatory mapping also ensure a strong local engagement in the project. This is the map of Cirebon. There are 4 palaces, and in this first year of research, we only mapping for the Kasepuhan Palace, and there are 3 others palace. Until now, we have the data acquisition in the September. It is for the data acquisition. It is for the building. We use the laser scanner, terrestrial laser scanner, and then the camera 360, and then the GeoSlam handheld laser scanner. And from that data acquisition, we have the current results. First is the city map. The city map generated from the LiDAR and UAV photogrammetry using drone. It is the LOD2 of city. It is the LOD2 of Kasepuhan area. It is one of object in Kanoman Palace. It's using the point cloud from GeoSlam. We can see the interior of the buildings. Why we use the geoslam? Because using terrestrial laser scanner, it's too much too much point we have to take in one building, but using the geoslam it's more effective. It is the object of Kasepuhan, one object of in Kasepuhan Palace. It is the house of the prince. It is the large house. We can see the buildings, the interior. This is the ground plan. Besides the using geoslam handheld laser scanner, we use the architectural draw, but only two dimension. It is the ground plan and elevation plane for the house, and it is the modeling from this data from architectural draw. We have to integrate the point cloud from the geoslam with the architectural draw to improve this building, but it's still on progress now. And then it is the base map and thematic map. In this research, we have to see the citizen relation and then family. From that, we can see the home location. Okay, it is the recommendation. For the next is collaboration implementation of digital twin in smart city. As we know, digital twin is a mirror image of a physical process. Visually matching exactly the operation of the physical process which take place in real time. So the digital twin can be used to smart city application. And then it's the collaboration implementation of digital twin in smart city, because Indonesia have programs to make implementing the smart city concept. There is 25 city for smart city concept, and then we are going to 100 smart city in Indonesia. And then this is, we can see human-centered design is an approach to system design and development that aims to make interactive systems more usable by focusing on the use of the system and applying human factors, ergonomics, and usability knowledge and techniques. In this, we can see the citizen as a sensor is for the participatory mapping, like this. Is one of the example in participatory mapping, but it's not in the Cirebon, but it is in our previous research in Jatinangor, Sumedang. And then we will create a smartphone application for data acquisition on site to support it, the participatory mapping. It is with LPPM ITB, there is aplikasi Sapa Diri dan Tetangga, but it's still on progress too. Yeah, it's give us the location of the citizen house. And then the citizen can using this application to and then it has to be collaboration in implementing the metadata Perpres One Map and Perpres CiGN, sharing informasi geospasial nasional. Okay, that's all from me. Thank you for your attention.